Well, hello, grade 9s. Sorry I couldn't be there with you today, but we're going to have a quick recap of the geometry that we learned. I'm going to go through the concepts fairly quickly, certainly a lot quicker than we did when we did it in class, and just recap all the things we learned about geometry. So here's the first thing. The that a straight line is made up of 180 degrees. This is what we learned. And what does that mean? Well, it means that if I have a straight line and I throw some other lines off of it, that they have to add up to 180 degrees. So this here and this here, those would both add up to 180 degrees. X plus y would have to equal 180 degrees. Not only that, but if I split it up even further, say that I took another little slice here and called that little thing z, now z plus x plus y has to equal 180 degrees. All of those added up. Anything that you see that forms a straight line, anything coming off of it, they all have to add up to 180 degrees. Also, along the same lines, all three angles in a triangle add up to 180 degrees. Oh, that kept going on me. There we go. So let's say this is 110 degrees in here. And let's say this is 30 degrees in here. We could use the information that they all have to add up to 180 to find the last one. Now I'm going to let that be x. We know that x plus 110 plus 30 have to add up to 180 degrees. Okay. Now we know that 110 plus 30 is 140. So what does that x have to be? Well, if you don't know off the top of your head, and these are easy numbers, so you do, once you add these up, you can subtract them from 180. I'll show you the algebraic way to do that as a quick recap of the algebra that we did. We could subtract the 140 degrees on both sides. And we have x on this side, and 180 minus 140 is just 40 degrees. Now most of the time we didn't set it up the algebra way. We just said just add these two things together. 110 degrees plus 30 degrees equals 140. And then on the next line you would say 180 degrees minus 140 degrees equals 40 degrees. And either way is fine. This way I recap using algebra to do stuff, and this way you just figure it out straight the way you would have back in elementary school. Now, because of that, we also have that the outside angle in a triangle, that's this one out here, or any other one on the triangle actually, is equal to the opposite angles inside the triangle. So let's say this was 40 degrees in here, and this is 110 degrees here. Then we would know that this in here equals 110 plus 40 degrees. Now, what that actually means, this would be 150, so we'd have this would be 30 degrees in here because this whole line has to add up to 180, and the whole triangle has to add up to 180. And we could extend any line from that triangle. This line out here, I'm going to do this in color. I'm going to say that this angle in here is the same as these two angles. And this angle here is the same as these two angles. And let's extend the line one more time. Put it up here. This angle out here, let's grab my colors again. This angle out here is the same as these two angles. Okay, so it doesn't matter which way you go, that angle outside will be the same as the two angles that are opposite it inside the triangle. Moving right along, any four-sided figure, which we call a quadrilateral, will have angles that total 360 degrees. So this is a quadrilateral, 1, 2, 3, 4 sides. And if I put the degrees in the corner, let's say that this one is 115 degrees. And let's just say that this one is 65 degrees. And let's say that this one is 130 degrees. and we have to find the one that's left over. Well, they all have to add to 360. So we could do 65 plus 115 plus 130, and that is 260, 70, 80, 90, 100, so 310 degrees. So what's left over down there? 360 subtract 310 equals 50 degrees. Okay. Going right down. Now this one was another rule that we used that is kind of hard to remember. Oh, come back, come back, come back. This doesn't like me tonight. It's not scrolling the way I want it. Anyway, to find out how much the angles add up to in any polygon, we need to multiply 180 degrees by 2 less the number of sides it has. So how many sides does this thing have? 1, 2, 3, 4, 5, 6, and 7. So it has 7 sides, which means that I have to multiply 180 by 5. And the way we got that 5 is by doing 7 minus 2. 2 less than the number of sides it has. So let me just grab my handy dandy calculator. And that number means nothing to you. I don't know what I was doing before here. There we go. 180 times 5 is 900. So this has 900 degrees if we add up all of these angles. Now it just so happens that this is a regular polygon. And for a regular polygon, if I want to know what this angle in here is, it's pretty straightforward. If it wasn't a regular polygon, that means that all the side lengths are different, and they can end up looking like Pac-Man sometimes. Okay, if they're all different, then there's no good way to find one unless you have the other 6. But if they're all the same, all you really need to do is do the total number of degrees divided by the number of sides. Now this had 7 sides, so 900 divided by 7. Back to my handy dandy calculator. Oh, and that 900 is ours, so we're just going to do 9 divided by 7 is 128.6 approximately. Approximately 128.6 degrees. Okay, next. The outside angle on any polygon. That's any polygon. That's why I have capital letters there, right? Any polygon add up to 360 degrees. Okay, so if I actually put all of these on here, which would be silly, it would not, not be very interesting, and it wouldn't look like a polygon anymore, but all of those things would have to add up to 360 degrees, and it doesn't matter how many sides it has. However, this is a regular polygon. So if I want to find out how much one of them has, again, all I need to do is divide 360 by how many sides it has. So how many sides does this thing have? A 1, a 2, a 3, a 4, a 5, a 6, a 7, 8, 9, 10, and 11. This is an 11-sided figure. Like our loonie. Did you know that? I think we talked about it before. The loonie has 11 sides. Anyway, we need to do 360 divided by 11, and that's going to tell us what this angle is in here. And by the way, this is a perfect polygon because, a perfect 11-sided polygon, because I used my little thing down here right there, to draw it. See? Right there. 11. I draw another one. So if we put a protractor on here, we would actually get this angle measurement. But right now, we will just do 360 divided by 11. 32.7, approximately 33 degrees, equals 33 degrees. Well, look, we've got a protractor. We're just going to test this out and see if it's about 33 degrees. So I'm just going to move my protractor and actually measure this angle. And looky there, that's just past the 30. I'm sure if we followed it out, we would see that it's at 30 degrees in there. Okay, or I think maybe I can make this protractor. Oh, I can pull up that. I forgot about that. I wish all protractors had this handy little arm on the edge. Let's pull it right up to there. And look at that, about 33 degrees. Okay. So it worked. Yay! Okay, next one. When two straight lines meet, opposite angles are always equal. Okay, we can throw our protractor on these two, except that they went away. Let's pull it back. Ooh. Okay, we call this the X pattern. What that means is that, oh, and it's going away again. Oh, I just can't win here. Come back, come back. Okay, there we go. If this is 110 degrees, then this is also 110 degrees. And because of our lovely 180 degree straight line thing, we can actually figure out the other two very easily. 180 minus 110 means that this in here has to be 70 degrees, and then this one across here would have to be the same thing, 70 degrees. So we can call that the X pattern. Carrying on. When two lines are parallel, so these two lines are parallel, and another line crosses it, and we call that line the transversal. Transversal. It creates identical intersections. So this here will be the same here as here because they're opposite, like we learned up here. And I'm going to choose a different color. This angle in here and this angle in here are going to be the same. And if we transfer those down, let's clone them and put them in here because they're going to be exactly the same. So identical intersections. And we give those things names, different patterns that we named after letters. So we learned 3 patterns with parallel lines. We learned that the elbows of a Z are equal. What do I mean by elbows? Well, this kind of looks like an elbow. And if I do this, there's another elbow. And inside those 2 elbows are 2 equal angles. I don't quite like having that there. Let's say inside those elbows are 2 equal angles. And so there's the Z pattern. Now the Z can go the opposite direction as well. So we can say that this is an elbow. It's just not crooked quite so much. And this is an elbow. And that's still considered a Z pattern, even though it's backwards and kind of stretched out. It still means that this angle inside the crook of the elbow is the same as this angle inside the crook of that elbow. So that is the Z pattern. Then there was the F pattern, and we're going to talk about elbows again. I'm pretty sure I didn't use that term before, but I want to try and get this across. We've got this elbow and this elbow. They kind of make what looks like an F. You could probably see it better if I did this one and this one. That looks a little bit more like an F. And those 2 elbows create identical angles in there. We'll call them X and X. And of course the F can be backwards as well, and upside down and all around. We can have this elbow and this elbow. And inside those 2 elbows, is the F pattern. One more, we got the elbows of a C. So how do we have the elbows of a C? Well, if we draw in a couple of angles and they join together, so there's an angle, and here's an angle, and they kind of look like they make the letter C. Well, inside those elbows of the C, here and here, those 2 angles are not equal. Nope. because this one is acute and this one is obtuse. So I shouldn't even put x on both of them. So I'm going to take away that x and call it a y. And we know that they have to add to 180 degrees. X plus y equals 180 degrees. So we learned an x pattern, a f pattern, and a z pattern. Those three things have equal angles, but not the C. The C has angles that add to 180 degrees. And after 15 minutes and 37 seconds, 38, 39, we're done. So carry on. You have some work to do out of the textbook, and we will take up any questions that you need to know tomorrow. Ta-ta for now.